My name is Christian Still. I'm from the University of Pretoria. Did this paper under the supervision of Prof. Elof, sitting at the back. And this is a chatbot, LLM-based access control mechanism. Hope you enjoy the talk. Okay, so in this presentation, I aim to tell you about large language models, their ability to perform a process called text-to-SQL, the potential vulnerabilities that come with text-to-SQL, and the foundations of a potential solution to how we can solve some of these vulnerabilities. A little bit of background. A recent advancement in natural language processing has been the advent of large language models, some of which I think many of you would have used already, such as OpenAI's ChatGPT and Meta's Llama. These LLMs have a wide variety of use cases. One such use case that is of particular interest to businesses has been their question answering ability for chatbots. What functionally makes a chatbot? Functionally, a chatbot is an application that is able to understand a natural language question, interpret the meaning of said question in a contextual level, and respond to the user in a conversational manner. Okay. Fundamentally, chatbots are trained on public domain data and only public data. So when it comes to businesses, this is a major limitation, as you cannot ask it anything related to the business. This is where the text-to-SQL process comes in. Text-to-SQL is essentially a question is proposed to the LLM then writes or generates a SQL query to be executed on a database. The database then returns a subset of data. The data is then passed back to the LLM with the question and the query, and the LLM is able to respond with an enriched answer. In the given scenario on the board, a user asks how many orders did John place. A SQL query is written to calculate the total orders where customer's name is John. This is executed on a database. 5 is returned as the total orders. This is then all passed back to the LLM, and the LLM responds with a nice little answer: John has placed 5 orders. So while text-to-SQL works really well, unfortunately there are some vulnerabilities. In a paper written by Peng, some of the main vulnerabilities that text-to-SQL faces is information disclosure, tampering, and denial of service. In this paper, we aim to solve the information disclosure problem. So understanding the problem better. Given a scenario where a business wants to allow a chatbot to have access to its orders and customers tables, to allow users to ask simple questions like order status, when their order might be delivered, even such things like delivery address to confirm it's the right place. However, many of you can see the malicious intent by some users here, where what's stopping a malicious user from asking about another user's orders, asking about another user's delivery address? At the moment, nothing, as you have to give the LLM access to the entire orders table, entire customers table. You don't get to pick and choose. This is the information disclosure vulnerability this paper aims to solve. Okay, understanding the problem further. However, you may be asking at this point, if LLMs really are as good as writing SQL as you say they are, why can't we just tell them about the access control policies and just let it be? Problem solved, right? Unfortunately not. LLMs have 2 main limitations. These are the context window size. Context window size refers to the amount of data that you can pass in for a single LLM call. This is often measured in tokens, and you pay per token only. So not only is the limitation the size a limitation, but the cost is also a growing limitation as businesses grow and more access control policies are required. The second is the stochastic nature of LLMs. LLMs do not give the same output for the same input. If you ask the same input 3 times, you'll get 3 different outputs. ChatGPT refers to this as the temperature or the creativity problem. Okay, this is not an ideal quality, as with access control, you expect it to be applied consistently throughout. The context window length problem is such a big problem that actually a co-founder of OpenAI, Andrew Karpathy, almost compares context window length to RAM limitations in early day computers, as can be seen by the LLM operating system that he proposed. With a little bit more background on LLMs and why LLMs are not an ideal solution, I propose a little bit more of a solution that follows more traditional database techniques, as I'll show you further. So, this paper focused on designing a prototype. The prototype was then split into 3 sections: the configuration of access control rules, the application of access control rules, and the enforcement of access control rules. Now it's getting dry. Oh, sorry. The configuration section aimed to make it easy and simple for users to define access control rules without having to understand complex SQL queries or complex database schema structure. So to give you a little bit more of a CLI output, so a CLI was chosen as it's a very easy but simple way to get going without having to get into too much detail. But as a simple output, here is an example of a user asking the LLM to write an access control rule to allow each customer to only access their orders in the orders table. The LLM will respond with a rule name, a query that enforces this rule, and then there's a human feedback loop to ask the human if they, or the user in this case, if the rule is what they expect. If it is, they can continue and save the rule. If it isn't, it's an interactive process between the user and the LLM to create the rule that they desire. To productionize this, I'd imagine that you'd have a nice UI that shows you the table with the rules being applied in real time. Second is the application process. So once you've defined a rule in the configuration step, you need a way of applying these rules to your data. This was done by making use of the JSON-B column provided in Postgres. And a has access attribute was then given to each row in the database that stores a list of roles that have access to each row. The final and most work section of the entire prototype was the enforcement section of the prototype. This is the section that aims to enforce the application rules that were just stored in the database. This section of the prototype made use of a middleware. This middleware was placed at the execute query section of the text-to-SQL process. This was to ensure one of 2 things. The first one is to ensure that every call has to go through the middleware. This enforces a consistency required by access control rules. Sorry. I've lost my spot. I'm terribly sorry. Sorry, I'll just carry on anyway. So the enforcement section was used to enforce the access control rules defined previously. And this will be a nice little example. So here's the CLI output again that was used. And in this scenario, I wonder if there's a pointer. Is this a laser on here? Whoa. Where's the laser? Sorry. Thank you. Sorry. So in this scenario, a question was how many customers are there? It's a nice simple query that the LLM writes out. In this, further down, the application middleware will define, using the has access, making sure that the role is used. So a temporary table is designed to only allow users, will only allow the query to have the rows that a user has access to. This way you make sure that the information disclosure problem is solved and the user never gets to access data that they don't have access to because of this. In conclusion, LLMs are incredibly powerful and are really useful for text-to-SQL. This allows LLMs to allows businesses to have domain-aware chatbots that allow them to access data that was not previously public knowledge. However, there are key challenges, such as the information disclosure problem. And this solution aims to solve that problem. Looking ahead at future research, a potential problem would be to get this to run smoother and faster, as it is quite a complex system to begin with. Another potential section of research is to look at the potential inference problem. Any single query on its own may not be a potential malicious query. However, 3 queries or 4 queries in a row could result in users seeing data that they shouldn't see due to inference. Thank you.